gotta record. All right. So as I say, I record the lesson so you guys can rewatch in case like you're at home or something, you miss a line of information, no problem. All right. Um, so this is Brightspace. Can everybody get into Brightspace? All right, no problem. So y'all all saw my messages, all right? Cool. You forgot to read them? That's no worries. All right, so first message is just a little welcome thing, tell you a little bit about the class. We're gonna be doing algebra, right? Some trigonometry, all the easy stuff, you know. And when you guys get to like linear algebra, you could get to the hard stuff. All right. Let's see what else we got here. So I want to talk about the course content a little bit. All right. So let's look at our syllabus. By the way, when you look at the announcement, the blue, right? Those are hyperlinks. So you click on them and then it takes you to another page. Right? So first thing I want to talk about is the syllabus. I already have it open, so I'm just going to click here, but just take my word for it. If you clicked it, it would open up in another window. Right? So this is our syllabus for the class right here. It's 28.5 college algebra with elementary trigonometry. Woohoo, all the good stuff. All right. These are textbooks for the class. You do not have to buy a textbook. It's all right here online. Right. You don't really need to look at it because I'm going to provide all the information for you. But if you're into reading, there you go. All right. All right. So we're gonna be doing fundamentals of elementary, intermediate, and college algebra essentials for the study of pre-calculus and calculus. All right. Topics will include linear equations, polynomials, factoring, roots, radicals, rational expressions, quadratic equation, and function concept, and trigonometric ratios. All right. Cool. This class is a co-requisite, meaning that it has like a remedial component to it, which is why my first lesson might be offensive to some of y'all. So I'm apologizing in advance, but we got to get through it. So, but like I said, in the meantime, if y'all want to just log into y'all homework and knock that out while I'm teaching, it's fine. I'm not offended. I totally get it. All right. So some of the outcomes we want to be able to do. We want to interpret and draw appropriate inferences from quantitative representations such as formulas, graphs, tables, use algebraic, numeric, graphical, statistical methods to draw accurate conclusions, solve mathematical problems, represent quantitative problems expressed in natural language in a suitable mathematical format, effectively communicate quantitative analysis and solutions to mathematical problems in written and oral form, right? Evaluate solutions and problems for reasonably using a variety of means, including estimation, right? And any mathematical methods to problem solve in other fields. Cool. All right. For the class, you will be allowed to use a calculator. I recommend the TI 36X Pro. All right. You guys could check that out. It's the black version of your calculator. All right. Yeah. That one does a lot more. A lot. Yeah. It's called TI 36X Pro. It's like $20. Huh? You can use decimals, but not on the test. You need the calculator for the test. You don't okay. Upstairs in the library, you guys can actually borrow the TI 83 calculator, right? Like if you don't want to buy one, you can just go upstairs and borrow it. I close at 5 though. That's the problem. Yeah, it looks exactly like yours, but black. 36X Pro. TI 36X Pro. Yeah. And then y'all know about academic integrity, right? Yeah, that's it. Yeah, that's it. Yeah. Yeah. So if anybody is allowed accommodations, right? No judgment. You guys have to first register with the disability service office over here, right? Or if you want accommodations, register with the disability service office, right? So that's their email. You guys can write that down or open the syllabus and take it, right? Their office is in Low Hall, room 211, and that's the phone number to contact them, right? Accommodations are things like extra time, you know, some accommodations could be like using a calculator, but I let y'all all use a calculator, so it's cool, you know, but this is something good to have, honestly. 100% confidential, does not go on your file, does not go on your record. It's up to you to disclose that you have the accommodation. All right. You don't as a professor, like you don't have to tell me why you have an accommodation. You just have to tell me that you have an accommodation. And that's it. And it gets honored. Right. And that's true for all your classes. Right. So don't feel like, oh, if I do this, it's gonna mark me and it's gonna hurt me for employment in the future. Not true. Nobody knows. It's up to you to say something, right? College is a little bit different. Like if you were when you were in high school, they might have identified you, given you like an IEP or something, right? But in college, they can't do that, right? It's discriminatory, right? So you have to actually say, hey, I'm entitled to this, and then they hook you up and they give it to you. All right. So just letting y'all know, no shame. If you want, like, sign up with them. Well, go ahead. Yeah, yeah. This one we're posted. I'm gonna get to that in a minute. Right. So these are all of our lessons that we're gonna go through for the summer. All right. I'm gonna make it as quick and easy as possible. All right. And that's basically our syllabus right there. One second. Is this it? Yeah. So a little bit about me. My name is Christopher Lee. This is my email. All right. So it's christopher.lee02@bcc.cuny.edu. If you have any questions, any concerns, email me. No problem. All right. You could catch me in CPH room 303. That's the tutoring lab. I'm also a tutor over there as well. So you guys are welcome to come hang out with me over there if you want. All right. My hours for tutoring are Sundays from 12 to 3 online, not in person, online. All right. And Thursdays all day from 12 to 6. All right. So Thursdays you might see me rolling in here a little bit late. All right. And that's because I'm coming straight from tutoring over here. All right. So yeah. This is the link right here to make an appointment for tutoring, right? You guys can make appointments with the tutors and sit down with them. This is summertime, so there's not that much demand in tutoring. So you might be able to do one-on-one tutoring over there, you know? But generally speaking, like if you wait for like finals time and all that, like tutoring is packed, you know, so you might have like two, three people that you're working with, you know. But yeah, take advantage. What I recommend doing, honestly, I recommend doing your homework in tutoring, right? You probably don't need the tutor to do every single question, but just to sit next to them while you're doing your homework, and then in case you have a question, you'd be like, hey, how you do this, you know? That could be a quick way to do your homework and all that. You know, stay on top of your homework. Stay on top of your homework, man. That's my greatest advice for you to you, right? Homework is like it's your way of practicing, you know, before you get to the test. right? With the homework that I give y'all, there's no penalty for trying a question, right? Just keep doing it until you get 100, right? All I want you to do is get 100 on the homework. I don't care how many times you do it. I don't care if you ask for help with it. I don't care if you use the calculator. Just keep doing it till you get 100. All right. Once again, the tutoring lab is in CPH room 303. Does everybody know where CPH is? No? Y'all should. That's where your department is. Yeah. All right. So, let me see what I can tell you now. This is the library, right? Y'all know Language Hall over here with the flags, right? So if you were standing in front of Language Hall and you look straight down the pathway there, there's a building with an arch, like a like a potato chip arch, right? That's CPH, right? So you walk underneath the potato chip, you go inside, go to the third floor, and tutoring is in room 303. All right. The tutors there are excellent. They can help you with anything. And all of the tutors know how to do this class. All right. If you guys were in statistics, only some of the tutors know how to do that. But this class, everybody knows how to do it. All right. So I recommend going. Go ahead. Yeah. Yeah. Calculators and your formula sheets as well. You know? I gave y'all this link here in case y'all curious for the Learning Commons. We have more than just math tutoring on campus. There's also a writing center that helps in writing. There's also specialty tutoring like chemistry, physics, biology, accounting, just to name a few, cybersecurity, all like there's a lot of tutoring on campus, right? So this is like a general like link to show you all the tutoring on campus. That's what that is. All right. So this is a breakdown for your class right here, right? Your final exam is worth 30%, right? Your in-class test that we're gonna have is gonna be worth 33%. I dropped the lowest test grade, all right? So I'm gonna give you 3 exams. I'm only gonna count the 2 highest. All right. Also, I allow you guys to do test corrections, right? So come in, you do the exam, I'm gonna grade it, I'm gonna give it back to you, right? The test corrections are up to you if you want to do it or not. So what you do for the test correction, you go to tutoring, right? You work with a tutor, right? And then you make sure that the test is good. Like you make it 100%. You bring it back to me, and I give you back half of the points that you missed. Right? Let me be clear about something. Go to tutoring, work with a tutor, not me. Anybody else but me. All right? Not me. All right? My philosophy behind that is that you guys are going to hear my approach, my way to answering all the questions, right? I'm recording it so you can rewatch my approach and my way to answering all the questions, right? If you get it wrong on the test, something that I said didn't make sense, right? So my philosophy is let me let you hear it from somebody else because maybe they might say it in a different way where it's just like, oh, that's what he meant, and then now you get it. So then now when it comes to the finals, light work, right? So that's how we're doing with the test, and then homework is 37%. Notice, right? Homework is the biggest percentage that y'all got out of everything. Stay on top of it. All right, that is an easy 37% right there. All you got to do is complete the homework. It's light. All right. And then over here, let me open this up real quick. Damn, I thought that would open. Let me see. Sorry about all this loading stuff. Did it open? Oh, it opened. Yeah. One sec. This is the flyer for tutoring, so you guys can have all the information. So tutoring is going to be from June 1st to July 30th, the whole class, right? Your tutoring hours are Sundays through Thursdays, right? Sundays through Thursdays. Sunday is online from 12 to 6, right? Monday through Thursday is in person or online, whichever modality you like better, from 12 to 6, right? And then you're going to be closed on holidays. There's no tutoring on Friday and Saturday. And you could use this QR code right here to make the appointments for tutoring, right? Like they ask that you make an appointment. You can just walk in, in case it's like last minute and you have a burning question, you can just walk in, but they do ask if you could make an appointment. All right. And also making an appointment kind of ensures that you have your spot with your favorite tutor, etc. The first QR code, that's the online suite for tutoring. So the way that online tutoring works is you're gonna log in, whatever, right? And then you're gonna be in a Zoom room, and then the secretary will greet you, and then the secretary will place you with the tutor, right? Online tutoring, in my opinion, is just as effective as in-person tutoring, you know? Um, bonus points if you guys have the ability to write on your screen. Like I can see I see some tablets out here. Like you guys will love online tutoring because you guys can do your problems in front of the tutor. If you can't write, that's okay. Like the tutors are trained, they know how to work if your computer doesn't have that capability. All right. And this is just more about the topics that they cover and the people that run the lab. Yeah, the important stuff is just this top part here. All right. And then if you didn't get this down, like that's the first link in the what you call it, in the announcements. Right. And then we have our cheat sheets. I'll go over those a little bit later. This last one right here, where it says web work cheat sheet, that's a cheat sheet to help you with your homework. Right. So sometimes you might do your homework, right? And you get the right answer, but for some reason, like the way that you're typing it in is not making sense, right? So this cheat sheet is to help you with typing in your answers to your homework, right? So that's that. Let's talk about homework. So you look at the announcement where it says homework access, right? All you have to do is just click on this link right here where it says BCC's web work, right? I'm sorry, no. Click on where it says homework link. Sorry about that. You just click on where it says homework link and it takes you directly to our homework page, right? We're going to be using web work for homework. And if you click the first link, right, it's going to take you to the general BCC web work page, and you have to just scroll down to where it says 2026 summer Lee Math 28.5 351, right? Right here, this is your login, right? Your login and your password are the same, right? It's your first name and then your last name. No space, no dot in between, just your first name and then your last name. So let's say that we had a student named John Doe, right? Their username and password would be John, all lowercase, DOE, Doe. One word, right? Username and password. And that's it. You could log in right now. You could try it out. Right? Forgive me on your first homework. We just got to do it. All right. And then from time to time, we'll talk about the formula sheets. All right. These are little information about them, and that's about it. Any questions so far? Anybody has? If you guys have a minute, like try logging in and seeing if you can open up the homework. Right? You opened it early already? You halfway done with it already? Okay. Okay. Right, and then just click submit, and that's it. Yeah, and it checks it right there. I'm not looking at how many times you try a question. I know it tells you that information. I don't care. I just want you to get 100. All right. Let's see. If we were looking at web work right now, like this is web work right here. What I do, oh, I gotta log in. Excuse me. Boom, 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 boom. So what I do, right? If you click on the link on the left-hand side, it says grades, right? The only thing I'm gonna look at the end of the class, right? I'm just gonna scroll down to the bottom and you see right here where it says homework totals. This one part right here, that's all I'm looking at, right? That's your homework grade. That's all I care about. Make that 100. That's it, right? And how do you make that 100? You go through each set, do all the questions. Boom, 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 boom. And that's all of it. Mine looks a little different from yours, but these are your homework sets right here. Only one of them is open right now. Another one is opening up tonight. But y'all could knock out the first one. Right? Is everybody can get in, no problem? Got in? Kel, you got in? All right, cool, cool. All right, so we good then. Do, 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 do. All right, so that's about it. So bear with me 1 second. Something I like to do. I always like to check my email just to let y'all know about any like announcements that might be happening on campus and all that. So I'm just checking right now. And I don't really have any announcements for you guys. If this was the regular semester, like I'd probably be telling y'all, yo, on Thursday, this is happening. Go check this out, da, 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 but nothing that I know of is happening this week. So just first week of school. Just welcome back. You know? All right. Let's see what this is. No, I don't need this. So as I was saying, most of y'all probably know this whole lesson already. Just bear with me for today at least. It's gonna be an easy lesson. Also, like, no shame in asking questions. I know I'm over here telling you guys that the lesson is easy. If you don't understand something, please ask. Like no shame. Right? Go ahead. Yeah. For integers, there is the algebra cheat sheet that I posted. Yeah. So the algebra cheat sheet, that one has arithmetic and algebra on it. And then the second cheat sheet is a trigonometry one. We're not gonna get to that till like the last week of school. So like you don't even have to really worry about that. Just worry about the algebra one for now. You know what? Let me see if I got it open. I can show y'all real quick. Since I'm mentioning it so much. Whoa, just had it. So to answer his question, even though he just walked out, all right? This is your algebra cheat sheet, all right? This is probably the only one you need to worry about for like 95% of the class, you know? But he asked about the integer part, like that. This is it right here where it says arithmetic operations. So we're gonna go through most of this. I'm not gonna say we're gonna get to all of this. Some of this stuff you're gonna see in Math 30, right, which is pre-calculus, but most of this we're gonna do over here. And then in like pre-calculus, you'll complete this, you know? So yeah, use this to help you with your homework. You could use this on the exam if you want to remember a rule. You know, it's all here. Mhm. Yeah. All right. So here's what we're going to first talk about. So we're going to talk about simplifying expressions with absolute value. All right. Everybody knows what an absolute value is in here? No? Yep. All right. So let's talk about it. A negative number is a number less than zero. So the negative numbers are to the left of zero on the number line, right? So this is a number line right here, and you see zeros in the dead center. To the left of that, these are all my negative numbers. To the right of that, these are all my positive numbers, right? You may have noticed on the number line, the negative numbers are a mirror image of the positive numbers, meaning that whatever numbers you see on the right-hand side, you also see on the left-hand side, with zero in the middle. Because the numbers 2 and -2 are the same distance from zero, right? Each one is called the opposite of the other. The opposite of 2 is -2, and the opposite of -2 is 2. All right. So opposite, right? The opposite of a number is the number that is the same distance from zero on the number line, but on the opposite side of zero. All right? Does that idea make sense? All right, cool, cool, cool. We got to build the vocabulary a little bit before we get into like the deep stuff, you know? But as I said, if you're bored, go ahead and knock out your homework. Doo, doo, doo. All right. So here's another example, right? The opposite of 3 is -3, right? And the opposite of -3 is +3 because each one of them are 3 units away from zero, right? So opposite notation, right? -a means the opposite of the number a. the notation negative, well, I say negative A, but the notation, the opposite of A is read as the opposite of A, right? But I like to say negative A. Right, so any number that I give you, if I say like, yo, what's the opposite of $20? It would be negative $20, right? Like you owe $20. Or if I say, yo, you owe $50, the opposite of that is you have $50. All right. Any questions on that? Good? All right. As I said, it's gonna be mad easy.
Negative.
Mhm. Right. So then that's the opposite of it. Yep. Yeah. All right, let's take it up a notch. New vocabulary word. All right, so we saw that numbers such as 3 and -3 are opposites because they are the same distance from zero on the number line. They are both 3 units from zero. The distance between zero and any number on the number line is called the absolute value of that number, right? So when you guys are doing your homework and they're saying, oh, what's the absolute value of this number? It's asking you, how many units away from zero is that number? Right? So let's give you the definition real quick. Absolute value. The absolute value of a number is its distance from zero on the number line. The absolute value of a number n is written as the absolute value of n, and the absolute value of n is greater than or equal to zero for all numbers. Absolute values are always greater than or equal to zero, right? So here's what they're saying, right? Let's say that I asked you, what is the absolute value of -5? I'm just making it up, right? I'm asking you essentially, how many units away from zero is -5? It's 5 units away. That's it, right? If I ask you, what's the absolute value of 7? I'm just making it up, right? Right. The answer is 7, right? 7 is 7 units away from zero. All right. Something to notice about the absolute value. Whatever is inside of it, if it's positive or negative, it gives you out a positive answer. Right? That's what it means up here when it says the absolute value of n is greater than or equal to zero. All right? Whatever numbers in the absolute value is going to give you out a positive answer. All right? Questions on this? One? Good. Exactly, to the zero. We're always counting to zero.
And then that number that we get is that.
Exactly. Yep. That's the distance. Mhm. Let me show you like up here, like in this example with the 3, right? So this 3 up top, this is the absolute value, right? So -3, absolute value of -3 is 3 units away from zero. Same thing with +3, right? +3 is 3 units away from zero. Hmm? That would be 6 units away. Yeah, yeah. But I'm not doing that though. Only with absolute value is always the zero. Yeah, got you. Got you. They were asking you how many units are in total. Yeah, I got you with that. Yeah. All right. Let me hit y'all with an example real quick, along with some more notes. Doo, 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 doo. All right, so for example, you know that -5 is 5 units away from 0. So the absolute value of -5 is equal to 5. And 5 is 5 units away from 0. So the absolute value of 5 is 5. For the same reason, right? How many units away from 0 it is. The absolute value of a number is never negative because the distance cannot be negative, right? The only number with an absolute value equal to 0 is the number 0 itself because the distance from 0 to 0 on the number line is 0 units, right? That's it. We now add absolute value bars to our list of grouping symbols. So when we use the order of operations, first we simplify inside the absolute value bars as much as possible. Then we take the absolute value of the resulting number, right? So if I give you guys a function, right, and there's something to do, like let's say you have to add two numbers together, right? You're gonna add the two numbers together in the absolute value bars first, then do the absolute value of that number, of that answer, right? It's basically what I'm trying to say is that the absolute value is a grouping symbol, like parentheses, right? It's the same thing like parentheses, except you're counting how many units away a number is from 0. All right. Mm-hmm. Yep. So just to recap, right? What are our grouping symbols? All right. So we have parentheses, right? We have brackets, right? Like the square brackets. We have braces, right? The curly braces, and now we have the absolute value. These are our grouping symbols, right? So remember, with grouping symbols, you always do what's inside of the grouping symbol first before you do what's on the outside. For example, right? Let's say you have a question like this on your homework, right? What you want to do, you want to start with the grouping symbol on the inside. So our first grouping symbol is the absolute value right here. But I can't start with that. I have to start with the parentheses on the inside first. All right. So I forgot my calculator at home. Someone help me out. What's 6 minus 2? Good, good, good. See, that's how I know y'all gonna get 100 in this class. Y'all already know that stuff. Mhm. All right, so then this is 4. All right. So what am I gonna do next? Good, good. What's 3 times 4? 12. Very good. All right, so it's absolute value of 19 minus 12. All right, this is the hard part. What's 19 minus 12? What is it? 7. All right, good, 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 good. So now I got 24 minus the absolute value of 7. What's the absolute value of 7? That's what's up. That's what's up. Now, what's 24 minus 7? This is a real hard part right here. What's that? 4? I don't even know. 17. Okay. And that's it. That's literally like half your homework right now, if you want to go ahead and do it. But just to make me feel good, you guys try one. Mm-hmm. Go ahead. Right. Good. No. Follow me. The same way you saw me do this, do the same process. Right? So like this was like the first step. All right. Then that's the, huh? Yep. Mm-hmm. Go ahead. Um, I feel like they're the same. Remind me, Gemma.
Gemma is grouping, exponents, multiplication, addition, and subtraction.
So my professor would love it if you use Gemma instead.
You're right, I think Gemma.
Yeah. But to be honest with you, it's the same thing. Yeah. But as long as you get the right answer, we good. Yeah. I do recommend showing your work. All right. Um, here's how it works, right? Let's say that this was like a test question, right? And you just wrote down an answer. Let's say you wrote down 18. I really can't help you with that. Like the answer's wrong. You know, that's just 0 points, right? 18 minus 2 is not complete. Well, you get partial credit for that. But here's the thing, right? When you show work, if you made a mistake, right, then I can see that, and then give you partial credit. But if you just give me an answer, and the answer is wrong, it's binary, like it's zero. You got it? Awesome. Yeah, tell me step by step. I'm not that good at math. Okay.
Then that down also.
Mm-hmm.
So then I multiply four times two, which is eight.
Very good.
Then minus go down to three.
Okay.
So the actual value of three, the minus is the same, it's outside.
Good.
So minus is the same.
Very good. Did everybody get that answer? Are you good? All right. Well, I'm proud of y'all. Y'all good. Ooh. Here comes another heavy topic. This is probably the hardest topic of all. Here we go. Adding and subtracting integers. Telling y'all, this is the hardest topic right here. So far, we have only used the counting numbers and whole numbers, right? So counting numbers, think of those as like the numbers you grew up with. Like, when you was little and like it was like, yo, like tell me your numbers, you'd be like 1, 2, 3. All right. Whole numbers, that's gonna be your 0, your 1, 2, 3. Same thing as the counting numbers with a 0, right? All right. Our work with opposites gives us a way to define what's called the integers. All right. So the whole numbers and their opposites are called the integers. So integers are like -3, -2, -1, 0, 1, 2, 3. So all of the whole numbers are contained within the integers. Right? So an integer is just the negative numbers and the positive numbers together. Right?
Negative and positive.
Yeah. That's what an integer is. All right. Questions on that? So what we're gonna be doing is we're gonna be adding and subtracting the integers. All right. I'm gonna need y'all help with this though, because I'm not the best at adding and subtracting. Mm-hmm. Yep. We just got to talk about it a little bit before we jump into it, right? So integers, right? Well, thank you. Yeah. Just a little copy and paste. Mhm. So integers, the whole numbers and their opposites are called the integers. The integers, for example, are like -3, -2, -1, 0, 1, 2, 3. All right. So most students are comfortable with the addition and subtraction facts for positive numbers. But doing addition or subtraction with both positive and negative numbers may be more challenging. So we're going to use two color counters to model addition and subtraction of negatives so that you can visualize the procedure instead of memorizing the rules. All right. I'm not gonna lie, I memorized the rules, but just bear with me. All right. So we let one color blue represent the positive numbers, and the other color red represents the negative numbers. All right. Now we're about to get it. Y'all gonna have to help me out with this one though. There's some hard examples right here. All right. So if we have one positive counter and one negative counter, the value of the pair is 0. Right? So they form a neutral pair. So the value of this neutral pair is 0. So 1 plus -1, 0. All right. So we will use counters to show how to add, right? So here's some examples of what we could add. Let's say we have 5 plus 3. What's 5 plus 3? That's what's up. Y'all good. What is -5 plus -3? I'm impressed. I'm not gonna lie. All right, I know somebody gonna get this wrong. What's -5 plus 3? Wow. All right, all right. What if we flip it around? What's 5 plus -3? 2. All right, I'm impressed. I'm impressed. Any questions on this? Y'all good? All right. Like I said, no shame. Ask your questions, you know? Let's look at how we do this with counters and then give you guys some more examples. Whew. Next example is real hard, I'm not gonna lie. Y'all might have to like count your fingers on this one or something. You know? Yeah. So the first example, right? 5 plus 3, you're adding five positives and 3 positives, which are both positive, right? So for example, you have 5 positives right here, 3 positives, you put them together. How many you have together? You have 8. 5 plus 3 is 8. Right? The second example, you have -5 plus -3. So you have -5 counters right here. You have -3 counters. You put them together, you have -8 counters now. All right. So here's the rule. When the signs are the same, the counters are all the same color, and so we add them. In each case, we get -8, either 8 positive or 8 negative. All right. Blah, blah, blah. All right. If you are adding two numbers with the same sign, you're just going to add the numbers and keep the positive sign, right? If you're adding two negative numbers, you're just going to add the numbers and keep the negative sign. Same sign, they just get larger. Questions on that? All right. So what happens when the signs are different, right? So let's say we're going to add -5 plus 3 and 5 plus -3. So when we use counters to model addition of positive and negative numbers, it is easy to see whether there are more positive or more negative counters. So we know whether the sum will be positive or negative. So -5 plus 3, right? You see how these are canceling out? We're left with -2, right? And when we have 5 plus -3, we have 5 positive counters, 3 negative counters. They cancel out the first 3. We're left with +2. All right. Long story short, when you have different signs, you subtract and keep the sign of the larger number. All right. Different signs, subtract and keep the sign of the larger number. Questions on that? Good. All right. Y'all got to help me out with this. It's hard right here. Oh, Lord.
Always keep the sign larger.
When they're different, when the signs are different. Yeah. Mhm. So how do I do this? What is -1 plus -4? That's what's up. -5. All right, this is a little bit harder. What's -1 plus 5? Good. All right, still a little bit harder. What is 1 plus -5? Say it again. -4. Good. All right, I'm impressed. Good, good. Do y'all want to try an example? Y'all feel like y'all got it? All right, I'm just gonna assume y'all got it. As I said, just humor me for today. So we will continue to use counters, right, to model the subtraction, right? So perhaps when you were younger, you read 5 minus 3 as 5 take away 3. When you use counters, you can think of subtraction the same way. So we will use the counters to show subtraction. So 5 minus 3, for example, -5 minus -3, -5 minus 3, and 5 minus -3. Let me see if y'all really know this. What's 5 minus 3? Good job. All right. What's -5 minus -3? What is it? -8? No. -2. Very good. All right. Yeah. What is -5 minus 3? -8. Good, good, good. All right. What's 5 minus -3? Huh? -2, right? No, no. No.
That's 8.
+8. Very good.
Let's hear, number. I don't know. Homework, anything else?
Yes, that's another way to do it as well, right? So what's a good example of this? Let me redo these real quick and I'll do it the way that you just described, converting it to the opposite, right? So instead of thinking of it as minus, right? Think of the negative as opposite, right? So this is 5, right? I'm looking at the first one. This is 5. And I'm going to ask you, what is the opposite of 3? -3, right? So this just becomes 5 plus, open parentheses, -3, which becomes 2. Right? Right. After the minus. Let's say I'm gonna do the second one. I'm gonna change the color because this is gonna get kind of jumbled up. I have -5. Now it says minus, but really what I want to know, what is the opposite of -3? +3, right? So that negative is going to become a positive, and this is going to become a 3 right here. So now -5 plus 3, that is -2. All right. That's another way to do it. Let me get another color real quick. So I have -5 minus 3. So what's the opposite of +3? Yeah, -3, right? So this becomes -5 plus, open parentheses, -3. So that's just -8, right? So every time I see the minus, I'm just asking myself, what's the opposite of what comes after it? So the last one, I have 5, right? Now it says minus -3. So what's the opposite of -3? +3. So this becomes +3. So call that 8. That's another way that you could do this. All right. So every time you see a minus, you just ask yourself, what's the opposite of whatever's coming afterwards? All right. Questions on that? All right. Just give me your options for your homework. All right. The first example, 5 minus 3, we subtract 3 positives from 5 positives and end up with 2 positives. In the second example, -5 minus -3, we subtract 3 negatives from 5 negatives and end up with 2 negatives. Each example used counters of only one color, and the takeaway model of subtraction was easy to apply. So, for example, say I have 5 counters here, I'm taking away 3, I'm left with 2. Or if I have -5 counters here, right, and then I want to take away 3 of the negative counters, boom, I'm left with -2 counters. All right. What happens when we subtract one positive and one negative number? We'll need to use both blue and red counters as well as some neutral pairs if we don't have the number of counters needed to take away. We add neutral pairs. Adding a neutral pair does not change the value. It is like changing quarters to nickels. The value is the same, but it looks different. All right. So this is a technique used to help understand what is going on. Da, 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 da. Let me get the rest. I know, I know. Just bear with me, bear with me. It's just for today. Tomorrow will be harder, I promise. Mhm. All right, so we have our -5 minus 3, right? Again, we want the opposite of 3, which is +3. Boom. Right? We have our neutral counter, so we're left with our -5, right? I mean, -8, sorry. Mhm. And over here, we have 5 minus -3. We want the opposite of -3, which is +3, right? So we're gonna take out our negatives, leaving us with our positives, gives us our +8. All right. Whenever I see a negative, I switch the whatever's coming after the negative to the opposite of it, of itself. Think of it like that. So like let's do A for example, right? I know you know what the answer is, but just humor me for a second, right? It's 3 minus 1. So instead of me doing the minus, right? I'm going to change that minus to a plus, and I want to know what is the opposite of +1, right? That's going to be -1. So 3 plus -1, that is 2. Does that make sense? Kind of? Yeah. Okay. What about the next one? Use the same technique. Not the 3. That first. Well, no, no, no. You're gonna keep the first term, right? You keep the -3. And then I want the opposite of -1. So instead of minus -1, I want the opposite of -1 plus, and then this is gonna be +1. Good. So now -3 plus 1 is what? Perfect. All right. Might not need a calculator for class after all. All right. You could go ahead and do it, but I'm just showing you guys a new way of doing it, right? If your old way works and you're always getting the right answer, I'm happy with that. Stick with your old way, you know? Yeah. So how about this one, right? We have -3, right? I'm gonna change this to a plus. What is the opposite of +1?
Negative.
-1, right? So what is -3 plus -1? Exactly, right? Not too bad. What about the last one? So I have 3 minus -1, right? So this is gonna give me 3, right? Plus, what's the opposite of -1? +1. When 3 plus 1 is? That's it.
Oh, positive.
Yep. Questions on this? Good? Yeah. That's what I'm saying. Log in and knock it out.
Question.
Mhm.
So since it's a very intensive class, it should be, how often are the homework?
Every day, I'm gonna give you them. Yeah,
Well, every day or something.
yeah,
And,
right. You don't want it to accumulate. So,
um,
so that's why I'm saying, like, I recommend like going to tutoring, knocking it out, and then just coming to class. Yeah. I mean, truthfully speaking, I posted the homework last night. Y'all could have went to tutoring and knocked it out before class. Truthfully speaking, you know?
but there was none. This morning, this morning.
Yeah. Got you. Yeah. Got you. Okay. All right, that's fair. That's fair. There'll be a new homework posted tonight. I don't expect you to be able to do it because it's tomorrow's lesson, you know? But if you finish tonight's homework, like the homework that's there right now, and you want to take a look at what you're doing tomorrow, go ahead. That's fine. Mhm. Do you guys get this or you guys want to try one? Good? All right.
This is the whole 29 questions, right?
Yeah. The first couple of homeworks for the course is gonna be heavy like that. And then after that, like the homework is gonna be very, very small. 5 questions, 10 questions. Like in the beginning, it's just a lot. So have you noticed that subtraction of sign numbers can be done by adding the opposite? Right, the next example, -3 minus 1 is the same as -3 plus -1. And 3 minus -1 is the same as 3 plus 1. You will often see this idea, the subtraction property, written as follows. So I want to show you guys something. So you guys remember the formula sheet that I was showing you guys earlier? By the way, if you guys want to print out the formula sheet and bring it to class, no problem. All right. That's why I put them there. On test day, I'll give y'all like a printout. All right. But real quick, you see like how we're talking about the subtraction property here, which is a minus b is equal to a plus -b, right? So you add the opposite of whatever comes after the minus, right? This is an example of a formula of something that is on the cheat sheet, right? So essentially throughout the class, I'm gonna be giving you guys the formulas, explaining them, but you guys will have the formulas with you on the day of your test. Right? So it's not too bad. All right. So subtracting a number is the same as adding its opposite, etc. Y'all want to help me out with this? This hard. Oh, dang. Let me see what we got for A. So this says, what is 13 minus 8? What's that? All right, 5. Good, good, good. What is 13 plus negative 8? Thirteen plus negative 8. What's that? It's also 5, right? So you see, subtracting a number and adding its opposite, same thing. That's the idea that we're trying to get here or build, right? Let's look at B, right? I have negative 17 minus 9. What's that? Negative 26. All right. What is negative 17 plus negative 9? Same answer, right? So on and so forth. I feel like you guys get the idea. Any questions? Anybody? Good? All right. Whoops. Okay. So tell me how to do this. And tell me step by step what to write. What should I do first? Good, good. So what is negative 4 minus 3? What is it? Negative 7, okay. What should I do next? What's next?
7.
Not 7 times 7.
This sometime.
Say it? Not 7 times 9. What were you gonna say? Okay. So you want to do the Mhm. Kind of. So what's the opposite of negative 7? Positive 7, right? So this is plus 7 minus 9. So what's 7 plus 7? And what's 14 minus 9? That's it. Questions on this? Just kind of putting it all together. Let's try this. Give y'all a minute. little bit harder. Could be. Let's see. I actually didn't do it out, so I don't know. So let's see. I have 8 minus -3. Opposite of +1 is going to be -1. So -3 plus -1 is not -1, -4, right? So this becomes 8 minus -4 minus 9, all right? So what's 8 minus -4? Good. So this becomes 8 plus +4 minus 9. All right. What's 8 plus 4? All right. So 12 minus 9, which is, say it again, 3. And that's it. All right. Did you get that answer? I forgot. No? No. You got it? Okay. Do you see where you made a mistake?
Yes, the negative. Minus the.
Got you. The outside negatives. That's another way to do it, right? Yeah. Speaking of which, let's move on to that. Go ahead. Hmm? Okay.
Minus, those whole numbers be negative numbers?
Not all of them. One of them would be positive. You know? So you would just do it from left to right, straight across.
There's no symbol between.
Yeah. That's it. Yeah. I didn't do it yet though. If you want, somebody lend me a piece of paper and just write all your names on it. And I'll be your attendance for today. Yep, thank you. Just say like 1 and then write your name. All right. So our next topic, we're going to talk about multiplying and dividing integers. All right. So since multiplication is mathematical shorthand for repeated addition, our model can easily be applied to show multiplication of integers. Let's look at this concrete model to see what patterns we notice. We will use the same example that we use for addition and subtraction. Here we're using a model just to help us discover the pattern. So we remember that A times B means add A, B times, right? So for example, you see right here where it says 5 times 3, right? That means I'm going to add like 3 5s together. 5 plus 5 plus 5. All right? That's what 5 times 3 means. Or the reverse, right? If it was 3 times 5, I'm going to add 3 5 times. So 3 plus 3 plus 3 plus 3 plus 3. Right? And then that's how you get the 15. Make sense? All right. If I say what is -5 times 3, right? I'm gonna be adding -5 3 times, right? So you have -5 counters plus another -5 counters plus another -5 counters. That's -5 times 3.
But it's basically fine for the first one. So
Mhm.
only by the first.
Well, you're just gonna add the first number that many times. That's what multiplication is, essentially. Questions about it? About multiplication? Right? Multiplication is just repeated addition. That's all it is.
Turn it up.
It's negative. That's true. That's true. Yeah. Yeah. Got you. Appreciate it, man. Usually right there. Yeah. So the next two examples are more interesting, right? What does it mean to multiply 5 by -3? It means subtract 5 3 times. Looking at subtraction as takeaway, right? It means to take away 5 3 times. But there is nothing to take away, so we start by adding neutral pairs to the workspace. All right. All right. Say you have 5 times -3, you're going to take away 5 3 times. All right. So you take away the +5 3 times, and then you're left with what's left over. And then take away -5 and 3 times. That's what that looks like. I don't want to dwell on this. And then you have what's left over. Blah, blah, blah. Let's get to the multiplication and division rules. All right, in summary, we know that 5 times 3 is equal to 15. 5 times -3 is equal to -15. -5 times 3 is -15, and -5 times -3 is +15. So notice that for multiplication, the two sign numbers, when the signs are the same, the product is positive. But when the signs are different, their product is negative. All right? So what about division? Division is the inverse operation of multiplication. So 15 divided by 3, that's going to give you 5. Because 5 times 3 is 15. In words, this expression says that 15 can be divided into 3 groups of 5 each, because adding 5 3 times gives 15. If you look at some examples of multiplying integers, you might figure out the rules of dividing integers. So if I say 5 times 3 is equal to 15, -5 times -3 is equal to 15. So if you do 15 divided by one of those numbers, let's say 15 divided by 3 is going to give you 5, or 15 divided by -3 is going to give you -5. Say I have -5 times 3, you know that's -15, or 5 times -3 is -15. So -15 divided by 3, that's going to give you -5. And -15 divided by -3 will give you +5. So division follows the same rules as multiplication with regards to signs, right? Let's look at the rules. All right, these are the multiplication division rules. So for multiplication division of two signed numbers, if you have two positive numbers, your answer is going to be positive. If you have two negative numbers, your answer will be positive. If the signs are the same, but the result is positive, right, then you have a positive and a negative will give you a negative, or a negative and a positive will give you a negative. If the signs are different, the result is negative. Blah, blah, blah. Try this out. So how are you doing? We good? All right, let's look at number one. So I have negative 100 divided by negative 4. What's the answer? Perfect. What about B? B's a little bit harder. I have 7 times 6. What's that? Good. What about C? This is 4 times negative 8. What's that? Negative 32. Okay. And what is negative 27 divided by 3? Is there any questions by anybody for any of this? Go ahead.
You did say
Mm-hmm.
you divide a negative with a positive negative, right?
Yeah. Mm-hmm.
Sorry.
Because same sign? No. A negative by negative, right? Same sign, positive, different signs, negative. So a negative and a negative is positive. A positive and a positive is positive. But if they're opposites, then the answer is negative. Go ahead. Go ahead.
Like, this act,
Nah. It's just the first homework that's like that. Yeah. But truthfully, you could probably finish it before class ends. You know, it's just this stuff. That's all it is.
First one's 25 or
25. You're right. My fault. I think I heard 25 and I wrote 24. That's my fault.
Oh,
Yeah.
somebody, they said 20.
Did they say 24? Oh, my fault. Mhm. Let me give you guys a special rule. It's a little trick. I use this trick all the time as well. So when you multiply by -1, so -1 times a is equal to -8. Multiplying a number by -1 gives you its opposite number. Just some basic stuff right there. All right. Let's talk about simplifying expressions with integers, right? So what happens when there are more than two numbers in an expression? The order of operation still applies when negatives are included. Remember, please excuse my dear Aunt Sally, that's the PEMDAS notation, right? So let's try some examples. We'll simplify expressions that use all four operations with integers, addition, subtraction, multiplication, division. And then just remember to follow your rules of operation. That's it. What's the answer for A, somebody? What is -2 raised to the fourth power? What is it? 16. Remember that this means -2 times -2 times -2 times -2, right? Negative times a negative is positive, right? -2 is +4, so this is +4, and this is +4. Multiplying them together, you get 16. It's that simple, all right? All right, what's the answer to part B? -16. Wow. I'm impressed. Right? Notice the difference between this, right? What does this mean? This means -1 times 2 times 2 times 2 times 2. Right? That parentheses thing matters, right? Because this part here was in parentheses, right? It got carried into every single number, right? Because of the parentheses. But over here, for part B, I don't have a parentheses, so it's just -1 times the positive twos. All right. Any questions on this? Nothing? All right. Well, I am happy that everybody's understanding. Do y'all need to see another example? Y'all feel like y'all got it?
This
Two parentheses? Give me an example. What you mean?
39 plus 5 parentheses.
Hold on. So you said -35 in parentheses like this?
39 plus -35 parentheses.
Let me see.
Actually, the
39 plus -35 in parentheses like that.
yeah.
All right.
Plus parentheses -16. Plus 9.
Just do it from left to right. Right? What's 39 plus -35? No,
4.
4, right? So this becomes 4 plus -16 plus 59. So what is 4 plus -16?
32.
Not 32, plus 4 plus -16. Not 18, not 20, -12, right? You have $4, but you owe me 16. Now you owe me $12, right? So what's -12 plus 59? What's that? You said 27?
27.
47? Good. And that's it. That's just how you do it. So just from left to right. That's all.
Parentheses.
Got you.
Now I got the wrong
Yeah.
place.
But you see, they're separated by that addition, so they can't be multiplied. They have to be next to each other for multiplication. Yeah. All right, let's try something new. I'll give y'all a minute. Try this. I feel like you all know and have enough information to be able to do this. All right. Let's try A. What do I do first? Exponent first. Good. So what's a -2 to the third power? Very good. So now I have 8 times -9 divided by, just gonna put in parentheses, -8. What do I do next? Good. What do you get? Yeah, that's right. So -72 divided by -8. What do I get now? +9. And that's it. Is there any questions on this? So just follow PEMDAS or Gemma, right? Parentheses first, exponents, or no, grouping symbols, whatever, first, exponents, multiplication, division, and then addition and subtraction. From left to right, the same way that you read a book. All right. How about B? How do I do B? All right, I'll take that. So this is gonna be 21. What else?
Two,
Uh, so what should I do next?
and you have two.
No,
Oh, wait.
remember multiplication, division before addition and subtraction, right? So no, we can't add yet. We have to get rid of the division first, and then we can add. Right? So what's negative 30 divided by 2? All right. Positive or negative? Negative, right? Different signs, right? They're going to be negative. So what's negative 15 plus 21? Very good. And that's it. I got you. I got you. These are like the harder questions in the homework, these things. You guys want to see another one or you feel good? One more? All right.
Yeah, I know you're rich.
I feel you. That's why we going to college.
Why we're here.
Yeah. I mean, everybody in here got good majors, so I think everybody gonna be rich. All right, here's another one you guys could try. I'll give you 2 minutes, then I'm gonna go over it because I have one more topic to show you guys for your homework, and then you're good. Even though you probably know how to do it already, just humor me. Got it? All right, tell me how to do A.
That gives negative 7.
Yeah, that's true. So this is 12 times negative 9 divided by negative 27. Good.
And negative 12, negative 8. Negative 8.
Not 81.
Oh,
It's okay. We could do it out over here. 12 times 9. That's 8. 1. That's 9. That's 10. 108. Yep. So positive or negative?
negative.
So negative 108 divided by negative 27. What's the answer? All right, positive 4. I'm just taking your word for it. I'm thinking about it. I'm not even sure.
Oh, because I miscalculated.
Mhm.
And it gave me 3, so. it-
Got you.
4.
I'm a cheat. I want to see. Yeah, you're right. Good job. All right, let's switch up the color. Oh, hold on 1 second. All right, we good. All right, we good. Next one, let's look at B. How'd I do that? Good.
over parentheses, -5, 6.
Okay.
30.
Good.
Another -27 divided by 3, that gives us -9.
Very good. What's -9 plus 30? Perfect. Any questions on this? All right. There's a lot more practice there for the homework. All right. Let me just show you guys one last really cool example, and then we could call it for the day. All right, so this is called evaluating variable expressions with integers. So, nice, nice. So remember that to evaluate an expression means to substitute a number for the variable in that expression. So now we can use negative numbers as well as positive numbers. So for example, right, we have 4x squared minus 2xy plus 3y squared, right? We want to figure out what that answer is when x equals 2 and when y equals -1. So what do you have to do? You have to literally take those numbers, take the 2 and the -1 and plug it into the expression, right? So this is going to become 4, but instead of the x, I'm going to write 2 squared minus 2 times, plug in a number. This is going to be 2. For the y, this is going to be -1 plus the 3. Instead of the y, I'm going to write -1 squared. Everywhere you see a variable, put a parentheses and put the value corresponding to that variable in the parentheses. After that, you guys already know how to do this, right? Tell me what to do here. How do I answer this?
You open up the file button.
Yeah.
So,
Remember PEMDAS.
yeah. Right, yes. So 2 with the power of 2, that's 4.
Good. So this becomes 4 times 4 minus 2 times 2 times -1 plus 3. What else? Very good. By the way, you guys notice how I do my problems? This is how you show work. You rewrite it and do it again. Don't do it in your head. Doing it in your head can sometimes make you get an error. All right. Anyway, what do I do next? Very good.
-2. 2 times -2.
Uh-huh.
Then -2 times -2 is
+4. Very good. And then this is really hard. What's 3 times 1?
+3.
Good. All right. Good. This becomes 20 plus 3. I'm going to call that 23. And that's it. Any questions about this? How to plug in numbers? We good? What?
Yeah. This, how, what is the sign between the 2 and -1?
Multiplication. So anytime you have two parentheses like this and they're next to each other, that implies multiplication. Right? Anytime, let me scroll up 1 second. Anytime you have two variables next to one another, like right here, right? The x and the y, that's multiplication as well.
Oh, one more thing. If you do compound stuff like, the 0 and the, negative, where the 2 negative letters.
Uh-huh.
Yeah, okay, that 0 stays, just to, that's,
Yeah.
and the perfect, that 0 stays, and then multiplies with the integer, to then give us 0.
0, right. That's another thing we didn't talk about it in class, but anything times 0 is 0. Right? So that's an important property that we were just mentioning. So any number that I give you, a times 0 is going to be 0. If I ask you what is 8 times 0, it's 0. Right? Another important fact that might help you with your homework as well. Anything to the 0 power is 1. So if I have 5 raised to the 0 power, that's 1. If I have 2026, right? Go Knicks, champions, right? Raised to the 0 power, right? That's their first championship, 1, right? All right. So with that information, you guys should be able to knock out your homework. Can I take this down? We good? No questions? So I always ask at the end if I could take this down because it takes a while